Can you hear me now? All right, everyone. One more time. My name is Dana. I'm a member of the education team here at the Aquarium of the Pacific, coming to you live from Long Beach, California. Very happy to have you joining us today. We're going to be talking about one of my favorite subjects, which is all about scuba diving. So if that's something that interests you and something you want to learn a little bit more about, maybe discover what it's like to be loaded up with all that gear and ask some questions about kind of the science behind diving, maybe some of the gas laws, maybe some of my dive experiences, please feel free to tune in, join us, participate throughout the program. We do have a phone number that we're going to be manning in the studio here. I have Luke outside who will take your questions and send them in to me. And I have Talia behind the screen here who's going to control what's going on behind me. So that phone number is 562-286-1838. And that's for live programming only. So right now it is Friday, July 10th. July 10th, how did that happen? July 10th, Pacific Standard Time at 1 o'clock. So if it is outside of that half-hour window, 1 to 1:30, instead, we encourage you to email us at live@lbaop.org. That way we can get to those questions when we're back at the computer and make sure that we get all of your answers that you're looking for. So with that being said, keep in mind that while texting today, standard texting rates do apply. Otherwise, let's go for a dive, if you will. So to start, we're actually just going to take a look at this screen behind me right now. What's going on inside of our Honda Blue Cavern exhibit? You can see there's all sorts of fish. We've even got a leopard shark coming across the screen. One of my favorite animals to see on a dive is a shark, of course. It doesn't happen often, unfortunately, but I always cross my fingers. What else do we notice? There's lots of algae growing, right? But what I want you to think about, besides the rocks and the sand and the algae, think a little bit more about those fish. How are these animals adapted to live in water? Now, an adaptation is something that an animal has or is born with to keep it alive and help survive in its habitat. So how are these fish adapted? What adaptations do they have to help them survive in water? I'm going to step off screen and let you think about that for a moment. All right, so some of the things that I'm noticing is how these animals are moving through the water. Now, I like to think I'm a really good swimmer, but in reality, my arms, my legs, I'm adapted to move around on land and support myself in an upright structure. We're a little bit awkward when we're moving through the water. So these fish, on the other hand, have these beautiful fins that allow them to kind of swim around nice and gracefully. They're very strong muscles, right, on the back here, the caudal. That's going to allow them to move through the water at varying speeds. So their fins is a really great adaptation. What else do you notice? Oh, yeah. Just like you heard, we have to breathe air. Fish, on the other hand, they have gills. So they don't have lungs in their chest like you and I. Instead, they have gills, which are on the side here. And the gills extract oxygen from the water, where our lungs extract oxygen from the air. Now, the air we're breathing is not pure oxygen. It's about 78% nitrogen, 21% oxygen, and only about 1% of other gases. Okay. But it's that 21% oxygen that's important for us. And so we're working hard to extract that out. Now, our fish, on the other hand, with their gills, even our shark that just swam by, they have gills and they pull from the water. So a little bit different, but we all need our oxygen. All right, I have a question for you. How is this fish not just laying on the bottom? And how is it not floating to the surface? Right? How do they find that nice sweet spot to allow them to hang out right in the center here? In fact, actually, if we jump into our amber forest exhibit, you'll see a really great example of some fish who can just hover. They're barely even moving. So we'll check it out. So Talia's going to pull that up, and then we'll watch some of our fish there. There should be a clip of it on the webcast. Yeah. So there we go. We got a thumbs up and ta-da! So check these fish right here. If you're looking at that one, it's just hanging out in the water column, right? It's not really working hard to be there. So as a diver, that is your goal. You're looking for that perfect balance where you're not sinking and you're not rising to the surface. And that way you're going to be able to conserve as much energy and last as long as you can underwater. So we've talked a little bit about the adaptations that fish have underwater, but instead let's take a different approach. How does a diver become a fish, right? What does our gear do for us that allows us to transform from this very awkward land animal into what I like to think of as graceful underwater swimmer, right? Let's check it out. Now, in order to do this, I'm going to bring in my good friend, Sherwood. Dun, dun, dun. Now, they're very tall, so we're going to have to kind of bear with the height difference there. I apologize. But what we're going to do is we're going to take a look at all of the different pieces of gear that Sherwood and I, as a diver, wear underwater and why we wear them, right? So it's not just because we look really cool, but actually each gear is functional. Now, oftentimes if you see divers that have way too much gear, it's over the top, right? You want to make sure that you're staying nice and trim while you're down there, and that way you're conserving energy. So we'll start with the basics, which is all Sherwood has, and then maybe we can talk a little bit about scientific diving. You might need a little bit more gear. Extreme deep diving, you might definitely need more gear, right? So let's just start with the basics here. We're going to start at the top and work our way down. So at the very top here, Sherwood has a mask. Now, a lot of people will refer to this as goggles, but in reality, goggles are just the eyepiece, right, that you might see Michael Phelps wearing in the pool. Masks for divers also cover the nose. And that's important because it's actually the nose that allows us to kind of equalize the pressure as we're on our dive. If you were to just wear goggles, as you go deeper and deeper and deeper in the ocean, there's actually a lot of pressure, and it can squeeze your eyes, and you can really come into some big problems. So this nose piece allows us to equalize using the air from our nose. Now, Sherwood also has a snorkel, which you might be looking at and thinking, but why, right? Snorkels are designed to pull air from above when you're hanging out on the surface. Well, divers don't always roll backwards off the edge of a boat. In fact, if you're a Southern California diver, you're probably doing a lot of shore dives. And what that means is you don't just walk out into ankle deep water and go, okay, here we go, and drop underwater, right? You're not going to see a whole lot. Instead, we like to do what's called a surface swim. So we're going to have to swim out away from shore so that when we drop down, we're dropping down into more like 20 to 40 feet of water. And so to do that, we just use our snorkel, right? There's no need to be breathing air out of our tank. Now, the next thing, I mentioned the tank. Let's go ahead and turn Sherwood around. So this part right here. Now, this is our scuba tank. And I want you to think for a moment. What's in here? If you're thinking oxygen, I want you to think again. What are you and I breathing right now? That's right. Earlier on, we talked about air, right? We're breathing air and the fact that our lungs pull oxygen from air, but it's not pure oxygen. Remember, it's that concentration of 78% nitrogen, 21% oxygen, and 1% other. But it's that combination that's combined inside this tank right here. So basically, imagine taking, all right, everybody take your arms nice and wide, and you're going to gather up as much air as you can, all right in here. And then you're just going to squeeze it all together, and you're going to pack it in to this tiny little spot. All that air that you just collected, right? So it's pressurized. It's condensed into a tiny little spot. This right here is called an 80 cubic foot tank. Now what that means is an 80 cubic foot room. Okay, so 8 by 10 by 10. Did I do that math right? We'll see. That's all compressed into one little room. Or I'm sorry, one little tank. And that's what our air supply is. It's highly pressured air. Just air, not oxygen, just pure air with a mixture of gases. Then we have to be able to breathe that, right? Only does it so good to have it on our backs. How do we get it into our lungs? And that, my friends, is where this comes into play. So this right here is a regulator. It's attached to the top of the tank. Usually will come up over your shoulder here, maybe under your arm, and it's going to sit right in your mouth, okay? Now what's cool about this is I mentioned that really high pressure inside of our tank. This regulator then has two stages that break that high pressure into something a little bit more breathable. Now, the first stage is attached on the top of the tank here, and what it does is it's going to take it from high pressure to medium pressure. Then, this stage right here actually takes it from a more medium pressure into what we call ambient pressure. And I want you to remember that word because we're going to talk about ambient pressure here in a little bit more towards the end of the class. So ambient pressure is the pressure of the space around you, right? So right now, if you and I were to take a breath off of a regulator, ready? It's just going to be pressure like we're at right here. We probably wouldn't notice much of a difference. However, if we were to go down to 80 feet underwater and take a breath, we're going to be taking more molecules out of this tank, okay? And again, we'll talk about this later on. Now, we've got the air. That's very important. Some other things that we need to know is how much air do we have left, right? A really common question that we get is how long do you last? And that all depends on our air supply. So this right here, it's very loose and spins. This is an air gauge. Now, it's pressure. It tells us how much pressure is left in our tank. And as we're diving, we actually have to pay attention to this throughout the entire dive so that you know where you're at. Sometimes you'll plan a dive with a buddy and you'll say, hey, we're going to dive and we're going to do what's called a reciprocal dive, where we're going to go out, we're going to enter from the shore, we're going to swim that direction, we're going to come back. Okay? And we'll say that our turnaround pressure, let's see, a full tank is usually 3,000. Our turnaround pressure might be 1,700, right? And that means I didn't use all of half my tank, but I used a good portion of half, and then I'm going to swim out that far, turn around, come back, and we always want to leave a little bit air. We never want to drain a tank, right? So our gauge, very important. Now, depending on your skill level, your comfort level, the conditions, that might last you half an hour, that might last you an hour. It really just depends on individual divers and what kind of conditions you are diving in. Another really important piece of equipment is this wetsuit that Sherwood is hanging out in. So this wetsuit is made of neoprene, which is like a thick rubber. And believe it or not, when you're in a wetsuit, you are wet. That's right. So people usually think that you're dry when you're diving, but in reality, if you're diving in a wetsuit as opposed to a dry suit, you're getting wet. Water enters into the suit, and then it's very tightly sealed around your wrists, around your neck, around your ankles, and your body heat will warm that water. And then it acts like a insulation layer, right? So just like marine mammals have blubber, our divers try to create a blubbery water layer in between, okay? Now, we also call this exposure protection because neoprene can help if we get bumped against a rock, if we get bumped against a buddy, right? It can also keep us warm and just protect from all the marine life around us, anything that we might be exposed to. And then this other big part right here, this whole jacket looks like a vest. These shoulder straps coming over. This is called the BCD, or Buoyancy Compensation Device. Now, what this is doing is this is going to help the diver find that sweet spot, just like our fish right here. Okay? So, when you think about it, we're all going to jump into a pool. Ready? On the count of 3. 1, 2, 3! Okay, what happened? Yeah, if you sunk to the bottom, and then what? You bounce back up to the surface, right? And that's because the average person in their birthday suit is what we call positively buoyant. Now, buoyancy is the force that's pushing up, that water is exerting on whatever object is in it. If you are heavier than the buoyant force, if you have more weight than the buoyant force, then you're going to sink. But if you have less weight than the buoyant force, you're going to float. Okay, so it kind of deals with density and weight and buoyancy and all sorts of other factors. But the buoyant force is equal to the amount of water that's displaced by an object. So if you have two identical objects, let's see. Okay, I'm running out of ideas over here. 2 skulls. We have bird skulls. All right. Imagine they're the exact same size. They're slightly different. But what if one of them was hollow and one of them was solid? They're the exact same size, right? So the water displaced will be the same, but one of them, the weight is less than the buoyant force, and one of them, the weight is greater than the buoyant force. So the one that's less is going to float, and the one that's greater is going to sink. Okay. So divers, another important piece of equipment that they're wearing is weights, because like I said, the average person is positively buoyant, which means you're going to float. The wetsuit, positively buoyant, means you're going to float. The tank depends. It can fluctuate, which is a little confusing, but usually at the beginning of the dive, it's more negatively buoyant, meaning it's going to sink, and at the end of the dive, it's slightly positive, meaning it'll help you float a bit. And then, in order to kind of balance all this out, divers will also wear a weight belt. That's right, folks. We still got more weight to add on, all right? So far, your tank can be like 20 or 30 pounds. All your gear can add up. And then I actually dive with, depending on who I'm diving with, and sometimes I have to pass the weights off to my buddy, right, to help him out. We'll say 15 pounds or so, okay? And so I'm walking around with a lot of gear on me before I even hit the water. But the reason we do that is because as a diver, do we want to hang out on the surface up here? No, right? That's snorkeling. We want to dive. We want to drop down into the water column. But are we walking on the bottom? Definitely not. We don't want to ruin any of the sea life or habitat down there. So instead, divers are trying to find this sweet spot, which means they have to make sure that they are dense enough to sink and counteract the buoyant force, but not so dense and heavy that you sink to the bottom. That's where this jacket comes into play, the buoyancy compensation device. This little hose also attached to our tank, okay? And you press a magic button, and it goes psh, 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 and you fill this air bladder up with air. And what that does is it's changing the density of the object, of the diver, right? And so that's going to allow us, if we put a little bit of air in, psh, 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 we might float up, right? And if we let all the air out, we're going to sink. So that's kind of what it's like to be a diver. The first thing you're doing is you're going out, all right? We're all geared up, ready to go. And we walk into the ocean, we do our surface swim, and then we look at each other and we say, we're going to go down, okay? And then we say, okay. And we grab that little hose and we go, and we have to equalize our ears because there's a lot of pressure down there. And we keep sinking. And then all of a sudden, we're gone, right? Now, I didn't sink all the way to the bottom because, like I said, we don't want to ruin anything on the bottom. We don't want to interfere with any of the sea life. So to get a little bit above the bottom, I'm going to go, and I'm going to actually put air in. And that's when I'm going to find that nice sweet spot to hover right over the seafloor, right? So now you kind of know what it's like to have all of your gear as a diver. Let's chat a little bit about what we're thinking about when we're on a dive, okay? So we do have some questions coming into the studio. Don't forget, friends, that question number was just back up. It's 562-286-1838. Go ahead and shoot us your questions if you're wondering anything about scuba diving. But one of the questions we got here is, what are you thinking when you're diving? What are you looking for, and what do you see? That's a really great question. So what we're thinking about is all of the above, right? Is my gear in check? What's my air like? What am I looking at? What's that over there? Did I feel something, right? There's so many sensory overloads when you're down there. But it's also weirdly peaceful because you're not talking to anybody, right? I mean, you might have a conversation with a fish or two, but for the most part, you're not talking with anybody. You're not really worried about what's going on up above because you're so focused on what's going on around you. As far as the things that we might see, we're going to be seeing all sorts of life. Of course, it depends where you're diving. This right here is a great example of what a California dive might look like. There's a lot of rock. Usually it'll be covered in algae and all sorts of stuff. We have giant kelp over on this side. So we have giant kelp right here, okay? And giant kelp is an algae that creates these beautiful kelp forest habitats here in Southern California, which if you've been tuning into our Aquarium Online Academy, you hopefully have learned a little bit and been able to explore some kelp forest habitats. And then within there, we have all these fish. These are all examples of rockfish. Down here in the corner, that bright orange one, we have a Garibaldi. That's the California state marine fish, just like this one right here. This is actually the most territorial animal that I come across when I'm diving. They're really only about that big, but they think they're about that big. Okay? And when I say that, what I mean is that they really, really like to protect their space. And so they'll actually come right up to divers and kind of chase them out of their little area. They're not afraid to assert that dominance, even though they're pretty tiny. What else? We have sea lions is another highlight. I always look for octopus. If I don't see an octopus on a dive, it wasn't a good dive. But our California sea lions, also another great dive. Because you don't typically see marine mammals very often. So if you get to see a seal or a sea lion come in, that's exciting. Seeing a shark, also huge highlight. This is beautiful. So this is actually very, very spot on for what a dive in San Diego might look like, or a very sea lion rich kelp forest habitat. So you can see there's some sandy bottom that was back over here. There's all sorts of algae growing and eelgrass, seagrass on the bottom. There's a lot of diverse habitats here, but what am I thinking about, right? So I mentioned when we drop down that I'm popping my ears. Have you ever gone up in an airplane and had to pop your ears, or driven up a mountain and as you're we'll talk about trap here in a second too, had to deal with like the pressure change? So I mentioned ambient pressure before, right? So what we're doing, ambient pressure is the pressure that's around you. Okay. And when you are standing right where you're at right now, yes, you right there, you are currently hanging out under what we call 1 atmosphere of pressure. And that's because from your shoulders up to the top, all the pressure that's on you up to space is 1 atmosphere worth of pressure, right? We forget that air and like the atmosphere around us has weight and pressure to it. Then if you just go 33 feet down below the surface of the water, you've doubled that pressure. So all of a sudden, your ears might be like, what is going on, right? So we have a saying in the dive community that is equalize early and often. So just like you might have to pop your ears when you go up in elevation, you have to pop your ears when you go down in elevation as well. So as you're dropping down, remember you're releasing air out of your hose here, and you're popping your nose the whole time. There's a couple different ways to do it. Some people actually, it's a really cool skill. They pop it with just their jaw. I can't do that, but you can try it. Yeah. Oh my gosh. What do I do if I get hungry when I'm swimming? Well, I'll tell you what. I actually was a swimmer. Like I swam in high school and I swam in college, and I like to keep snacks on the side of the pool. But I don't think that's what the question was about. What do I do if I'm diving and I'm hungry? My dive buddies and I have a rule. And that rule is you are not allowed to talk about burritos. You are not allowed to talk about hamburgers. You are not allowed to talk about all-you-can-eat buffets while diving. Okay, so my rule is don't say the food word until after the dive, and you have to be broken down with all your gear, because once you're underwater, you really want to enjoy that moment. It's quite a bit to put all your gear on, get out to the water. You'd hate to drop down and be like, I'm really hungry and I'm not going to enjoy this dive, right? So try to eat a pretty good breakfast, and then be prepared for a great lunch. I like that question. So that's something else that's on my mind, right? Sometimes you do get hungry. I personally don't like seafood, so that doesn't really seem to affect me at all. But I get cold on dives, and that's when I'm really going to start deciding whether or not I'm going to call the dive, which means we're going to end it. I like to dive like this. And then when I get really cold, that's when we know it's time to get out, right? So divers, I mentioned the wetsuit as exposure protection. We also wear gloves. We also wear hoods. We also have what we call booties. They're little neoprene boot, like zipper boots. We have all sorts of ways to stay warm underwater. And then if you're really diving in a cold place, like maybe if we were going to Alaska, oh, that'd be so cool. You would learn how to get dry suit certified. Now a dry suit, let's bring Sherwood back out here. A dry suit is just like a wetsuit in the sense that it's going to cover your whole body. But unlike a wetsuit that's kind of porous, a dry suit is actually not. So you are, just like the name suggests, dry. It has really tight seals on the ankles, the wrists, the neck. It's got a waterproof zipper. Nothing gets in. And air is a better insulator than the water that a wetsuit contains. And so in a dry suit, you actually stay much, much drier, which actually is cool because that's kind of how our sea otters stay warm in such cold habitats. Their fur is so incredibly thick. Look how cute they are. Their fur, just like this, is so incredibly thick that their skin never gets wet because there's so much air trapped in there. Have you ever been to the aquarium and seen the otters kind of fluffing their fur or constantly grooming themselves? Well, that's what they're doing, is they're trying to fluff it up and make sure that there's plenty of air so that they stay warm. So there are ways to avoid getting hungry on dives, right? There are ways to avoid getting cold on dives. So then the other main thing on my mind is, of course, the pressure. Right? If I'm equalizing often enough, it's really, really hard when you get deep, so deep that you haven't equalized, because your ears really start to hurt, right? And then you have to be careful to come back up, and there's all sorts of things. Pressure really plays a part in our lungs as well. I'm always thinking about what my depth is. If I'm at 30 feet, I don't want to look down and all of a sudden find myself at 50 or at 15 feet, right? Because ambient pressure, remember, if we take a breath off our regulator, grab your regulator, it's the same pressure as what's behind us, which means the molecules that I breathe in are as expanded as they are around me, okay? But at depth, all that air that was compressed into our tank, I'm going to take a breath, and I have to fill the same space of my lungs as I do when I'm on the surface, but I'm pulling more molecules out because they're more densely packed. Now, if I take that breath and then all of a sudden I shoot up to the surface, what happens to that air? So this is a gas law talking about pressure versus volume. As pressure on an object, a flexible object like our lungs or a balloon, you can think of a balloon. As pressure increases, volume decreases, right? So that's what happens when we go down to depth. But what happens if I breathe at depth and then I lose pressure? So as pressure decreases, volume increases, and you can actually blow out your lungs, right? So I'm constantly paying attention to what my depth is. Now, you have to really be completely not paying attention, right? So we have computers just like our gauge there. It's not like I'm looking at the bottom and being like, yeah, I think I'm still in about 30 feet. No, I have a depth gauge, and it's going to tell me exactly. I point to my watch because my computer is a wrist mount, which means I dive like this, and I kind of look, and I'm constantly paying attention to where I'm at. So that's something that I'm thinking about and focusing on a lot. Now, friends, we are wrapping up in the studio here. I talked a lot about diving. I talked a lot about the gear. I hope you learned something that you maybe sparked your interest. Maybe you want to learn a little bit more about the pressure of diving. You want to learn more about figuring out your buoyancy, right? You might want to learn a little bit more about the exposure risk that I talked about, talking about the wetsuits or the dry suits. So if you found yourself kind of wondering things and wanting to discover more, I do encourage you to check out different resources, learn a little bit more about scuba diving. I do want to remind you that you don't have to be a marine biologist. You don't have to be a researcher to be a diver. I have a lot of friends who dive who have all sorts of professions. So look into it if it sounds interesting to you. Learn as much as you can. Otherwise, thanks for joining us today. I hope you have a wonderful Friday afternoon, and we'll see you back here at 2 o'clock. Alrighty, bye-bye.